Hi friends, on this day, in this video, you are going to study operators in C programming. We are having different operators. Totally, we are having 10. In this video, we'll try to complete all the 10. So the first one is assignment operator, then arithmetic operators, compound assignment operators, increment and decrement operators, relational operators, logical operators, conditional operators, bitwise operators, then Sizeof operator and comma operator. Let's see one by one. The first one is assignment operator. So number one, assignment. Now this is already it is represented by equal to symbol. Now most oftenly you might have seen whenever you declare a variable integer, for example a, you might be writing something like this. Maybe a default a value you may be assigning, that is a is equal to 10. So here you can see a is equal to. Now whenever you use the assignment operator, you will be having first of all LHS, left hand side, is equal to RHS, right hand side. Now right hand side may be a constant may be there. For example 10 is an integer constant. Maybe a expression may be there. For example you may be writing C is equal to a plus b, means a expression a plus b, the result of a plus b must be stored in variable called as C. Or you may even write like this, C is equal to, or directly you may write a is equal to b is equal to c is equal to d is equal to 0. Means you want to initialize all the variables to value 0. So this is regarding assignment operator. At the right hand side, whatever is there will be stored in the left hand side. Another rule is the left hand side must be always a variable. You cannot write like this. For example, you cannot write a plus b is equal to c plus d. You cannot write like this. No, this is not allowed. You must have only one variable or operand. Now a, b, c, d are called as operands and plus equal to symbols are called as operators. You must have only one variable. Say I'm saying a is equal to, here you can have any number of variables. Maybe a variable, for example a is equal to b, b is a variable, the value of b will be stored in variable a. Or you may be having a is equal to some single quotes, then some d, means here d is a character constant, the value d will be stored in a. Or you may be having an expression like c is equal to a plus b, c is equal to a plus b. This is the first one. Let us see the next one, arithmetic operators. Number 2, we are having totally 5 arithmetic operators: addition, subtraction, multiplication, then quotient, then remainder. So these are the few arithmetic operators what we are having. Now for example I'm having two variables, integer a is equal to 5, or let us take 10, and b is equal to say 5. So I'm having totally two variables. Now what will be the result? I hope you know printf. I'm not going to use the third variable, I'm directly using the two variables only. So I'm going to print addition. So we can write here addition is equal to, or add is equal to f2, add is equal to, then double quotes, comma. Now here I'm going to write a plus b. Here you are using sum, addition of two numbers, then the same for respect to subtraction, the same with respect to multiplication, the same with respect to quotient, the same with respect to remainder. Now you can change this add. Here add will be modified to mul. You can say multiply, or you can write mul. Here I am writing mul. Then here you are going to write sum. Now if you write like this, all the results will be displayed in the same line. In order to print in the next line, you are going to write /n. /n means go to next line and print this line. Same thing with respect to the rest. /n If you give space, one space will be printed, otherwise there won't be any space. So what will be the result here? Let us cross check the result. Here you will be getting add is equal to 15. In this case you are going to get the result as 15. Here you will be getting the result as 5. Here you will be getting the result as 50. 10 into 5. Here you will be getting 10 by 5 means 2 is the quotient, and here a percentage b means 10 divided by 5 and the remainder will be 0. So this is arithmetic operations. Let us see the third one. Third one is compound assignment. Compound assignment, that is plus is equal to minus is equal to asterisk is equal to slash is equal to and modulus is equal to. So these are the operators what we have. Now we have seen just now that C is equal to A plus B expression. For example, I am having an integer variable, say A. Now what I am going to do is, you may initialize the value in the same line or in the next line. I am going to initialize the value in next line is equal to 10. Now I am going to write A is equal to A plus 1. Now what is this line? Means I will be having a box. That box will be having the value 10. The name of the box is A. The name of this box or memory location, we are going to call it as a memory location A, and it will be having some unique address. Now at this line A value is 10. What we are going to do here, take the 10 plus 1, 10 becomes 11. A plus 1 is 10 plus 1, 11, and store back the result into A. So here you will be getting 10 plus 1, 11. This line. So here you can see that at the left hand side you are having variable A, at the right hand side also you are having variable A. Now if both the sides you are having variable A, you can write the same thing as A plus is equal to 1. This is equal to A is equal to A plus 1. A is equal to A plus 1. In the same manner, if I am going to write A minus is equal to 1, then what is its equivalent? A is equal to A minus 1. Then I'm going to write A into is equal to 5. What do you mean by this line? A is equal to A into 5. Then same thing, A slash is equal to 2. A is equal to A by 2. Same thing, A percentage is equal to 3, means we are dividing the value by 3. So in this manner we are going to use a compound assignment. This is another method to add a variable, but the condition is at the left hand side and the right hand side you need to have the same variable. A is equal to A plus 1. You cannot write these type of variables for C is equal to A plus B kind of things. You cannot write for, if I am having C is equal to A plus B or A plus 6, you can't write C plus is equal to 6, because at the left hand side you are having C, at the right hand side you are having A. Let us go back to the next one, that is, let us see the increment and decrement at the last. Let us go to the relational operators. What is this one? Serial number 3. Then let us go with the relational operators. Number 4. The relational operators what we are having is less than, then a greater than symbol, then a less than or equal to. Now in mathematics you will be having less than symbol and we will be having an underline for less than, that is for less than or equal to. But in C language or in computers we don't have that concept. We don't have that symbol at all. So you are going to write less than, then a equal to symbol. Then the same thing, then greater than or equal to. Then now you may be seeing that in mathematics if A is equal to B means you are comparing two values, but here in order to compare two values you need to use double equal to, because single equal to is assignment operator, double equal to is comparison operator, whether both the values are same or not. Then you will be having not equal to. So these are the relational operator. In mathematics not equal to means equal to will be slashed, but here we don't have that symbol. So let us see, let us take two variables, integer A is equal to say 6 and B is equal to say 8. Now I will be writing printf directly, printf percentage D. Why we are writing percentage D? Because we'll be having these relational operators. For example, I'm going to compare 6 less than 5. 6 is less than 5? No, right? If it is not less than 5, we are going to get a false. False in C language will be represented by a 0. And if I write like this, 6 is greater than 5. Yes, 6 is greater than 5. Now here we are going to get a true. In this case, true means we'll be getting value 1. So in C language, true means 1 and false means 0. Now depending on the condition, all the relational operators are going to give you true or false, that is 0 or 1, and 0 and 1 is a number, and that is an integer number without a dot. So I'm going to write here percentage %d. It depends on the output every time. So comma, I'm going to write a greater than b, that a is greater than b. If it is yes, then we are going to get the 1 as a result, otherwise you are going to get 0 as a result. Let's see the next one. Printf. Now here I'm going to write less than, then I'll be writing greater than or equal to. You can check the outputs to greater than or equal to, then whether both are same. If both are same, you are going to get 1, otherwise you are going to get false. So how to modify this program in order to do it in the C editor? So what you are going to do, you are going to add few lines here. Say I'm going to write the first main here, then I'm going to write a flower bracket, then these lines, then close the flower bracket. So main, then a flower bracket, then declaration of the variables, then printing all the variables with the relational operators, then this one. In other words, these are called as conditions also. Conditions also. Let's get to the next one. What is the next one? Logical operators. Number is 5 because we have left increment or decrement there. Logical. Logical operators, we are having only 3, and then or the pipe symbol above your enter key, then not. Above enter key you are having a pipe symbol, a line. So this represents. So first one is and or and not. Now I'm having a condition, for example, a greater than b is one condition. I want to check whether a is also greater than c. Two conditions, a must be greater than b, a must be greater than c. Then both are true, then I'm going to say a is bigger than b and c, for example. So what you're going to do, you're going to add an ampersand, means and. A is also greater than c. Is it so? If it is so, then we are going to say a is big. Is that right? So here we are using AND operator. In another case, what we are going to do is, we are going to check at least one is correct. Means either a is greater than b or a is greater than c. At least one condition is true. So what you are going to do is, here you are going to keep a variable, say a is equal to, or say p is equal to, then here q is equal to, then here at the last you are going to add a semicolon. Semicolon. Then here also a semicolon. So p will be having either value 1 or value 2. What you are going to do, you are going to combine two conditions, a greater than b and a greater than c. So for example, I am saying this as expression 1, E1, and we are going to call this as expression 2, for example. So what will be the truth table? I'll be having E1, then I'll be having E2, then E1 and E2, for example. Yeah, let's take a box for this. This is called as truth table. Might be you might have studied in your inter. So here you can write either true and a true. You will be getting true. True and true is true, and the rest are false. True and false is false. Then false and true is also false. Then false and false is also false. If both the conditions are true, then only you are going to get true. Now here, instead of writing true, you may also write 1 and 0 combinations. 1 and 1 is 1. The same thing, 1 and 0 is 0. Then 0 and 1 is 0. Then 0 and 0 is also 0. Okay, true or false, or 1 or 0. AND operator. Now if you copy the same truth table, if you check for OR operator, it will be something like this. OR operator. Now at least one is true, your condition is going to get true. You're going to use OR operator here. 1 or 1 is 1, 0 or 1 is 1. At least 1 is there, you are going to get the value as 1. Means for only 0, 0 case, the value is 0. So this is logical operators. And one more is there, not. Not 1 means you will be getting the value as 0. This is equal to 0. 0 means same thing, 1. Any positive number will be giving you, not any positive number will give you 0, not 0 will give you 1. Not 0 will give you 1. Not 1 will give you, that is 0, or any number, maybe 150, not 150 also gives you 0. So I'm going to write Z is equal to not A. Then you need to print all the three variables, P value, Q value and Z value. Okay, let us get back to the next one. After logical, you are having conditional operator. So real number is 5, 6. Yeah. Next one is, sixth one is conditional operator. We are having a conditional operator. The syntax is something like this. You will be writing a condition. Then this condition will have a question mark. Then you will be having true value, then a colon, then false. So this is the syntax. For example, I will be writing here Z is equal to, in brackets. Now we are going to write the condition A greater than B, for example. Now if it is true, then I need to return the A value into Z, or I need to return B value into Z. Means, for example, I'm going to take what is A value, what is B value, then you will get understood very easily. Integer A is equal to say 5 and B is equal to say 4 for this example as of now. Now what I'm saying, then I need to have one more variable called as Z, because we are using it. Now A value is 5. In other words, what do you mean by this 5 greater than 4? Whether 5 is greater than 4? Yes. If it is true, then A value must be stored in Z, otherwise B value must be stored in Z. If the condition is true, after question mark, whatever is there will be copied into Z, otherwise whatever is there in B will be copied. So here what it is going here, actually value 5 is going to Z, otherwise value 4 will be going to Z. 5 will be going to Z or 4 will be going to Z. This is another example. Now this is one conditional operator, a alternate to if condition. If condition we are going to study in forthcoming lectures. Now here we are going to write the condition first. Now there is another example. I'll give you A is equal to say 4 greater than 6. Is it true? I'm going to write here 4. Otherwise I'm going to write 6. You may write different values also. There is no need that if 4 is greater than 6, you need to give 4 only. I'm giving 10. And I'm giving 20. It depends on the condition. If the condition is true, whether the condition is true, I don't think so. The condition is not true. 4 is not greater than 6. So A will be holding the value 20. If the condition is true, A will be holding the value 10. Now another important thing is, in this condition will evaluate you either a value 1 or value 0. So if I write all the time A will be having the value 10. Now if I write like this, B. Now here I write 0. 0 means false. If it is false, all the time B will be having value 20. Here in this line B will be having value 20. Here in this line A will be having value 10. Let us see the next one. Seventh one. After conditional operator, you are having bitwise operators. Yeah. then Sizeof, then comma. Yeah, let us see bitwise. Now bitwise operators we are having, one is called as single ampersand, that is called as AND. Then we are having a single pipe symbol called as OR. Then we are having XOR. Then we are having NOT. Then we are having left shift. Then we are having right shift. These are the bitwise operators what we are having. Let us see one by one what it is. Now AND operator means we will be working on bitwise operators means binary numbers. Binary numbers. So basic rule of binary numbers is 2 to the power of 0, that is value 1, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, 32, 64, 128, 256, 1024 and so on. Now what are these? These are binary equivalents. Suppose I am having a number 1001. What is the decimal equivalent of this one? Means if I am having a 1, I am going to write down the above line for a quick understanding. Wherever 1 is there, I am going to add the top one. So for example, 1 means 1 plus 8, that is 9. This is binary equivalent of value 9. Value 9. What we are doing here, I'm going to draw this table in my mind, not on the paper. Whenever you get the conversions, you should not do on paper. It must be in your brain. Now what is these? 2 to the power of 0, 2 to the power of 1, 2 to the power of 2 and so on. Now whenever I get a 1, use that number and add it. 8. Now here we are having 1 plus 1. 1 here means 8 plus 1, I'm going to get 9. Suppose I want to write what is the binary equivalent of 12. 12 means 8 plus 4. So what is that I'm going to write here? 1 and 1, the rest are zeros. So this is binary equivalent of 12. Suppose I want to write the binary equivalent of 16. Not 16, let us write for 15. Yeah, binary equivalent of 15. What is the binary equivalent of 15? Can I see 15 here? No, I'm having 16. So 16 minus 1 is 15. So that is equal to 8 plus 4 plus 2 plus 1. 8 plus 4 plus 2 plus 1 is 15. So I'll be writing all ones. So this is binary equivalent of 15. This is a chart. Now based on this chart, wherever 1 is there, you will be adding. Now let us work on this bitwise operators. Now here I'm having a value 1 and a value 1. If I'm using AND, bitwise AND, then what is the equivalent? Let's just check once. Yeah, 1 and 1, I'll be getting the result as 1. 1 and 1, 1 and 1 is 1. Then 1 and 0 means if I'm having a number 0, then the result will be 0. AND operator. Then let us copy this one again. Then 0 and 1. At least 1 0 is there, we are going to get the result as 0. Then this is 0 and 0, you will be getting 0. This is regarding AND operation. You can pause the video, you can note down these things. AND, binary AND. Now if I'm writing here OR, what will be the result? Just let us check this one. Let us write the OR symbols first. Then yeah. So 1 or 1 is 1. At least one value is there, I will be getting the result as 1. At least one bit is 1. So I will be getting here 1 because 1 or 0 is 1, 0 or 1, I'm having 1. So I will be having 1 and so on. Now let us go with XOR. XOR means here I will be having a tilde symbol. Raised to power symbol, not tilde, power. That is called as caret symbol also. So let us draw the symbols first. Now XOR, when both the values are same, you will be getting 1, otherwise you will be getting 0. 1 XOR 1 is 1 and 0 XOR 0. Two values are same, then I am going to get the value as 1. The rest are 0. 0 or 1, 0. Then 1 or 0, 0. So this is XOR. Now we are also having a tilde, means not 1. What is that tilde? 1 means I'll be getting the result as 0. 0 is equal to not 1, and the same one, 1 is equal to not 0. Not 0 means 1, not 1 means 0. Let us see left shift and right shift. Let us write a program for all these things first. Yeah, let us see left shift. This is left shift, and this one is called as right shift. These are also operators. Now right shift and left shift, let us write a simple expression. So let us write z is equal to 8 left shift 2, means you need to move 2 bits to the left. And let us say one more variable, p is equal to 8 right shift 2. These are the two expressions what you are going to write. You may write a right shift 2, b right shift 2 also, no issue. You can directly take a constant value here, or you can take a variable here. Now let us see the first one, 8 right shift 2, means what is the binary equivalent of 8? 8 is nothing but we are also having 8, so 1 will be the 0 0 0. So if you see the chart here, so 8 means you need to place 1 over here, then the rest are zeros. So I have done the same thing, 1 0 0 0. Now this is binary equivalent of decimal number 8. Binary equivalent of decimal number 8. Now what you need to do, let us take the first one, right shift. P is equal to right shift 8 to 2, means I have to move the digits to the right. Now what is this? This 1 will be copied here, it will be moved 2 bits here, then this 0 will be copied here. Now I am going to forget about these two zeros. These two zeros must be removed. These two zeros must be removed. And what about these two spaces? Add zeros. Add zeros. Now this is the new number what you got, and this is stored in P. So what is this equivalent? This is 1 and 2. So this is equal to 2. So in other words, this line will be having the result as 2. What we have done, we have moved this bit. Now this bit is having, I'm going to give a color to this one as of now. So I'm having 1, this one is shifted 2 bits, so I'm adding 2 bits zeros to left, then I'm moving this over here. Then this 1, I'm having 1, this 1 will be moved to right here. That's it. I'm going to ignore the rest of the 2 because this is a 4-bit number. Remove the zeros and add 2 zeros. So this is our new value, that is 2. Now let us take the next one. Z is equal to 8 right shift 2. Now the same number I am going to take for 8. 1 0 0 and 0. This is binary equivalent of 8. Now what we need to do, we need to move the bits to left, means I am going to copy this one, I am going to paste it here. What I have done, I have moved these numbers left. Then what I have done, I have added 2 zeros to left. So this is called as right shift. Now you have shifted the numbers. These are the numbers what you have shifted, and these two are the new numbers what you have added. So let us check what is this number equivalent. So 1, this is 2, this is 4, this is 8, this is 16, this is 32. Means the result is only 1 is there for 32, for the rest we don't have. So the result of this number is, you are going to get the result as 32. So this is left shift and right shift. Let us see one example for all this. So what you are going to write is main, then you are going to write lower bracket, then integer a is equal to 8, then you are going to printf, and let us take one more variable, integer a is equal to 8 and comma b is equal to 4, for example. Then you can write f2 %d because you want to print in decimal number, again back, not in binary numbers. So %d a and b, then a or b, then XOR. You can use /n, caret symbol, then you can write not a. Not a means wherever 1 is there, 0 will be placed, 0 is there, 1 will be placed. For example, we are having 8, a is having 8, 8 means 1 0 0. Now this is binary equivalent of 8. Now what is not a? Not a means 1 becomes 0, 0 becomes ones. all ones. So this is 1 plus 2 plus 4, that is 7 is the equivalent of this not A. Then you can write left shift A, left shift 2, check the result, then A, right shift 2. So this is the program for binary or bitwise operators. Bitwise operators, and or XOR, not, left shift and right shift. See the next one, Sizeof. Sizeof is going to give you the size allocated for a variable. In some books this is called as a function, in some textbooks it is said as an operator. Let us consider this as an operator and let us see what is the size of. Now integer in some compilers like Turbo C is going to allocate 2 bytes. Now in our GCC compiler it is 4 bytes. What is this exactly? If the compiler is 16-bit compiler, it allocates 2 bytes for integer. But most of the compilers what we are presently using, that may be a Turbo C, that may be a Dev C++, that may be code blocks, that may be your Linux GCC compiler, it is 32-bit compiler. Yes, it is 32-bit compiler. So what it is doing, it is giving 4 bytes for integer. It is giving 4 bytes for integer. Compiler. So integer is having 4 bytes. Then you are having long is also going to have the same 4 bytes. Then you are having float is also having 4 bytes allocated. 4 bytes of memory is allocated for a variable you are declaring as float. Then character will be having only 1 byte, it is going to allocate. Then you are having double, it is also having, double is having 8 bytes. Then I'm having one more variable called as long double. For this it is going to allocate 12 bytes, 8 plus 4, long double is 12. So these are the basic ones. You can try in other ways also, like short is there, unsigned is there, all that you can try. So how to print this? So these are all numbers. You can see these are all numbers, and the two without decimal. So these are integers. So I'm going to write here %d, because I'm going to get the result as 4 or 8 or 1 or 12. So these are integer numbers. So I'm going to write d. Then you are going to write without space size of int is one method. Then you may be writing something like this. You may also write the same thing in this way. Here I am going to write directly 10. 10 is an integer constant. It won't print 10. It is going to print how much size is allocated to store the value 10. 10 is integer constant. Or you may declare a variable. Say here I am declaring integer x. Now here you can directly write, instead of 10 you can write x. Size of x. X is the integer, how much memory is allocated, 4 bytes. In all these 3 cases you may be getting either a 4 value or a 2 value. Most often you will be getting size as 4. Now for the rest you can try like this, size of, that is long, float, character, double, etc. Let's see the next one, that is comma operator. 9th one is, now where you are going to use comma operator. For example, I want to declare more than one variable. Now here you can use commas, or you want to assign a variable value also. A is equal to 10 comma b is equal to 20 or 30. Now here also you are using comma. Yes, in these cases you are going to use comma operator. Let us see the last one, that is 10th one, increment or decrement operator. That is plus comma minus. These are the two operators for what we are having. Now here first plus means increment, and the next one is plus means increment, and you are having one more operator called as minus, and this is called as decrement. Minus is decrement. Now in plus we are having two types. For example, I am writing a plus. Now this is called as that is called as post increment. Why? Because after variable a we are having plus plus, so it is called as post. And if I am having first plus plus then a, then it is called as pre increment. This is called as pre increment. There won't be any space for a here. We'll be writing semicolon. The same thing here. So post increment because plus plus is after the variable, pre increment because the operator is before the variable. So let us copy the same. We're having two more. Now that is a minus minus. Minus minus means post decrement because minus minus is there after the variable. Post decrement, the same thing. This one is called as pre decrement. Decrement. Now what is this, all this thing? In other words, you are going to write, for example, integer. Suppose I am writing integer a is equal to 50. Then if I write a is equal to a plus 1, this is equal to become 51. A value will become 51. Or you may write a plus is equal to 1. Means a is equal to a plus 1. In other words, here the value is 50. Here the value becomes 51. Here the value becomes 52. The same thing if I write a plus plus, the value becomes 53. Means I am again adding 1 to this. Now here plus plus a is also same. It is also going to increment the value by 1. 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 So here it is going to become 54. Now what is the difference between a plus plus and plus plus a? Means a plus plus is something like post increment, or it is something like postpaid. First you are going to use, then you are going to pay for that. In the same manner, first you are going to use the value of the variable, later on you are going to increment the value. For example, I am having integer a is equal to 20, for example. Then I am going to write printf percentage b comma a plus plus. Just concentrate. What we are doing here, a plus plus means post increment. First use the value, then increment the value. Means here it is going to print value 20, but a value becomes 21. A value becomes 21 after the line is executed. After this line is executed, a value becomes 21. But here what value is printed? It is going to print the value 20. Then it is going to increment the value of a. Now I'm going to give the same example here, but with pre increment. Pre means first increment, prepaid. First pay the amount, then use it. Pre increment means first increment the a value. 21 becomes 22. Then display the value. Now 22 will be displayed. I hope you understood. Let us see this again. First you are going to declare a variable a is equal to 20. Means I will be having value 20 in a. 20 in a. Now here it is going to print the a value. A plus plus means first print the value 20, then increment the value to 21. Post increment. First use it, then increment it. Now here in this line, first increment it because plus plus is before it. Increment it, then display it. So a value becomes 22. Now here we are going to get the result as 22. The same is with respect to decrement also. Now here in this line you are going to write decrement minus minus. So then next line, let us modify first. Yeah, now here I am having value 22 will be printed and a value is 22. Now here what you are doing here, you are decrementing. Post decrement means use the value first, then decrement. So what is the result here? You are going to get, what is the value? 22 will be displayed. Then after displaying 22 becomes 21. After displaying 22 becomes 21. Post decrement, use the value first, then decrement. So a value is 22 first, print the 22, then minus minus 21. Now here minus minus a pre decrement. First decrement the value, then print the value. So 21 becomes 20, then it is going to get printed next 20. So these are the 10 operators what we are having in our C language. So for this video, that's it guys. Have a nice day. Subscribe to my channel. and inform regarding this video to your friends. That's